Went through yesterday and I tallied up the questions that, if you will, people voted for at the end of class, the questions they wanted me to go over. So these were the most commonly requested questions. So the first questions that I wanted to look at are 7 and 8 and 10 on the front page based on this diagram. So in question number 7, question number 7 says, if the measure of angle 2, what is the measure of angle 10? And that's not possible. And the reason that it's not possible to make a conclusion there, take a look. I know that 2 and 10 are corresponding angles, but look, H and J are not parallel. So because H and J are not parallel, even though angle 2 is 55, I don't know that angle 10 will be 55. You have to know that you have parallel lines before you can say that the corresponding angles are congruent. So question number 8, the correct answer in number 8 is 63. So if angle 13 is 63, the question was asking you to find the measure of angle 12. So on this question, you have a transversal crossing parallel lines. So those alternate exterior angles really will be congruent. So in question number 8, the measure of angle 12 really is 63. Question number 10 is a little bit different. The measure of angle 1 is 135, and you want to find the measure of angle 4. So let's label it. If angle 1 is 135 degrees, notice here are my parallel lines, here is my transversal. But notice 1 and 4 aren't a type of angle pair that we've studied. So my advice is that you take angle 1 and you put it with its corresponding angle at angle 3. And now you can see how to find angle 4. 3 and 4 are a linear pair. So if you take 180 and subtract 135, that's where the answer on number 10 of 45 comes from. So labeling the picture, hopefully that's a good strategy in order to help you keep organized when you're doing your calculations and finding your measurements. So on the second page, questions 13, 15, 17, and 18 were commonly requested. So question number 13, if angle 5 is congruent to angle 8, then what conclusion can you make? So here's angle 5 and here's angle 8. So if those are congruent, J is the transversal, and we are crossing the lines W and Z. So I know W and Z are going to be parallel. So line W is parallel to Z, and the reason is because you have alternate exterior angles that are congruent first, and that's allowing you to make the conclusion that you have parallel lines. Now number 15 goes the other way. You're starting with the parallel lines. So you're starting with H is parallel to J, and you're told angle 8 is 121. So now I know that H is parallel to J, and angle 8 is 121, and my job is to find the measure of angle 4. Well, 8 and 4, those are corresponding angles. So because I already know the lines are parallel, I can say that the corresponding angles are congruent. So the measure of angle 4 should also be 121, the reason being parallel lines give you corresponding angles that are congruent. So we're basically working in the opposite direction as we did in number 15. So questions 17 and 18 were very frequently requested, and here all you're doing is trying to write an equation that suggests an angle relationship that would force H and J, force those two lines to be parallel. So look at angles 3 and 8. Wow, angle 8 seems to be popular. So angle 3 and angle 8, those are alternate exterior angles. So if I can force those angles to be congruent, it will make H and J parallel. So the relationship that you want is 11x plus 42 equals 6x plus 82. If the alternate exterior angles are congruent, so if their measures are equal, that will force H and J to be parallel. And if you do the algebra there, I'm not too worried about the algebra. Oops, you can't see what I was doing, I apologize. So again, the 3 and the 8 are alternate exterior angles. If I can force them to be congruent, so if I can force their measures to be equal, then I know that H and J are going to be parallel. So I'm not too worried about the algebra. What I'm really worried about, not worried about, but what is important to me is that you show me the equation. So the algebra is review for all practical purposes. So question 18 is similar. We have to look at angle 1 and angle 4 and decide how can we relate angle 1 and angle 4 in order to force W and Z to be parallel. So notice angle 1 and angle 4. Those angles are not one of the special angle pairs that we've studied, but that's why I did one of the previous questions, because if you want angle 1, if you want these two lines, W and Z, to be parallel, then you can force the corresponding angles to be congruent. So you can force angle 1 to be right here. And if you force angle 1 to be there, you're saying the corresponding angles are congruent. That forces those lines to be parallel. But what that really means then is angles 1 and 4 are supplementary. So the equation that you would want to write here is that the 12x minus the 33 plus the 18x minus 12, that equals 180. So that relationship, those two angles are supplementary. That would force W and Z to be parallel. Same thing in terms of the algebra, you would get an x value of 7.5. So going on, again, I'm not surprised by this. So frequently requested were the proofs for questions 23 and 24. So I want to talk you through those solutions. There are many ways that you can do question 23. This is just one of many ways. So what's important is you're starting with parallel lines. Because you are starting with parallel lines, your reasons are going to start with parallel lines. And we want to work our way from 8 to 9. So I started at 8. Here's where 9 is. That's where I want to finish. So I went from 8 to 16. So I said 8 is congruent to 16 because my parallel lines give me the corresponding angles that are congruent. And from the 16, then, I can connect that directly to the 9. Those are alternate exterior angles. So I know angle 16 is congruent to angle 9 because the parallel line will give me alternate exterior angles that are congruent. And then I can connect these relationships together using the transitive property to connect angle 8 straight to angle 9. Angle 8 is congruent to angle 9. That's the proof statement. Again, there are many alternative ways that you could do this. I suppose you could go counterclockwise around the figure also. There are a number of different angle pair types that you could use. The key, though, in this proof is you are given the parallel lines, so your reasons have to start with parallel lines. That's a little bit different in question number 24, and my advice in question number 24 is to follow the arrows that I put in here. So if G is parallel to H, first you need to work along a transversal that crosses those parallel lines. So you don't want to work along the transversal F, which crosses my parallel lines G and H, because I've only got one angle there. I'm going to work along the transversal E, where I can see angles 1 and 2. If those G and H lines, if they're parallel, then angles 1 and 2 are congruent because starting with the parallel lines in the given, I can say the alternate interior angles are congruent. Then I can take, because I know 1 is connected to 2 and 2 is connected to 3, I can directly connect 1 to 3. Angle 1 is congruent to angle 3 by the transitive property, and then it's about using this angle pair to make your conclusion. So, but 1 and 3, if you look in the diagram, that's a pair of corresponding angles that are congruent. So going along the transversal G, the corresponding angles being congruent, really will force E and F to be parallel. So you're starting with the congruent angles first, and then you're making a conclusion about the parallel lines. That comes second. So after the proof questions, some of the algebraic style questions. So for question number 26, this is a question where you have to realize that this exterior angle, the 4x plus 1, you're really stuck. The exterior angle theorem says that that exterior angle is equal to the measure of the two remote interior angles added together. So really, the only way to write the equation in this situation is here. You have a little bit more flexibility in question number 27. Notice that both pairs of lines that look parallel really are parallel. So my advice is to start labeling corresponding angles that you know are congruent. I know this 47 can be put here. Those are corresponding angles if I move down and to the left, if you will. I can also move to the right, so I know this is a corresponding angle to the 47. Frankly, I can now move along this transversal down and to the left. I know this this angle, that corresponding angle, is also a 47-degree angle. And so now I can see my relationships. I can already see that z is 47, so I'm done with that. And then I can write some really simple equations to find x and y. So here, these are vertical angles. So I can write the equation that 5x plus 2 equals 47. That's going to give me 9 for x. And then up here, I have a linear pair. So you could say y minus 17 plus 47 makes 180. I suppose you could subtract 47 from 180. That would be 133. So you could label this angle as 47, this angle as 133, and then you could just say y minus 17 equals 133. There's another way that you could write that equation. Add 17 to both sides, you get y equal to 150. So then the last group of questions that people asked about was essentially the last page. So let me at least take you through my answers and my comparisons there. So my advice in a question like number 30 is just to count the slopes. So here the rise is down 3 and the run is positive 1, right 1. For line number 2, we're going down 9, so that's the negative 9 and right 3, positive 3. But then notice you should reduce those, both of those reduce to negative 3. So then tell me what's going on. The slope of line 1 is negative 3, so is the slope of line 2. So I know those slopes are equal. That's what makes line 1 and 2 parallel. So it's important to tell me the slopes, tell me how they're related. If they're equal, you have parallel lines. If they're not equal, then you don't have parallel lines. Same thing on number 31. I used the rise and the run to calculate the slopes. So for line number 1, the rise is up 5, that's my positive 5, and right 3, that's positive 3. For line number 2, I'm going down 4 units, so that's my rise of negative 4, and my run is right 5, that's positive 5. So you should report your slopes. So the slope of line number 1 is the 5/3, and the slope of line number 2, that's negative 4/5. But to be perpendicular, these need to be opposites and reciprocals. So you could basically say, because these are not opposite reciprocals, line 1 and line 2, they can't be parallel. If they were opposites and reciprocals, so if I had 5/3 and negative 3/5, because those are opposite reciprocals, then you could say the lines are perpendicular. So I know that these are opposites, one's positive and one's negative, but they have to be opposites and reciprocals, opposite reciprocals, and they're not. So lastly, on questions 32 and 33, the first thing you have to do, if you want to be perpendicular to this line, you need to find this line's slope. So you need to solve for y. So I subtracted x from both sides and divided by 4. So that negative 1 over 4 gives me my slope of negative 4. So its opposite reciprocal is positive 4 over 1. So that's the slope I want to use when I write my equation in point-slope form. So then I can just subtract my y coordinate, y minus 2, and subtract my x coordinate, x minus negative 5. Same thing on number 33, but I'm interested in a line that's parallel to this line, so I still need to find its slope. So I need to subtract the 15x from both sides, and I need to divide by 10 in order to get the y by itself. And the negative 15 over 10 reduces to negative 3/2. There's my slope, and I want to use the same slope in order to make a parallel line. So my coordinates for the point that I'm passing through are 3, negative 4. So I need to take y minus negative 4, that's y plus 4. Here's my slope, and then x minus 3. And there's the equation of my parallel line. Good luck on your test.